Okay, for question 2, part A and B are just simple factorising. So for part A and B, you're looking for any common factors that go into both of the terms. So A, I'm saying what factors go into 6 and 9? The biggest number that go into both is 3. And are there any letters that will divide into x squared and x? Well, that's just x. If I've divided by 3, the 6 here becomes a 2. Divided by x, so x squared becomes x. Plus divided by 3, the 9 will become 3. And I've divided by x, so this x will vanish. If I do the same with B, the numbers are 10 and 15, so the highest factor is 5. If I look at the letters, I've got an x squared here and an x here, so that most I can take an x out of both, and a y squared, so I can take a y out of both. Then divide by 5, 10 becomes 2, divided by an xy, so I've got an x left, divided by 5, 15 becomes 3, divided by xy here, so I've got a y left. Right, parts C, D and E are slightly different. And these ones are the quadratics that go into 2 brackets. And you can tell because you'll always have x squared plus or minus some number of x's plus or minus a number at the end. It'll always be the same format. If you remember, we said these go into 2 brackets next to the front. And for this one, the 2 numbers in my bracket have to multiply to give this 15 and add to give 8. So 2 numbers that multiply to give 15, add to give 8, must be 5 and 3. So that's 5 and 3. Okay, this time I've got 2 numbers that multiply to give 16 and subtract to give 6. So 2 numbers that multiply to give 16, and when I take one away from the other I get 6. Must be 8 take away 2. And for the last one, 2 numbers that multiply to give 12 and add to give 7. So 2 numbers that multiply to give 12 and add to give 7 are 3 and 4. But note I want to make them equal to minus 7, so I want minus 3 and minus 4. Okay, for question 3, we want to solve these simultaneous equations. So to solve simultaneous equations, we need either the same number in front of the x's with the same number in front of the y's. So I notice here I've got the same number in front of the x's. So I don't need to multiply the equations by anything. I could multiply them to get the y's the same, but I'm not going to. I'm going to leave them as they are. So now I need to decide, do I want to add or subtract the equations to get rid of these x's? Well, if I added, I'd end up with 10x. So I must want to subtract or take away. So 5x take away 5x is nothing, which is what we want. Minus 2y take away 8y is minus 10y. And 33 take 18 is 15. So if minus 10y is 15, then y must be 15 divided by minus 10, which gives you minus 1.5, minus 1.5. And all I need to do then is, I just need to put that in to one of the equations. So I'm going to choose the bottom equation. So if I say I want to substitute this into 5x plus 8y equals 18, so if y is minus 1.5, I'm going to do 5x plus 8 times minus 1.5 equals 18. Now minus 8 times 1.5 is minus 12. Add 12 to both sides, I get 5x equals 30. Divide by 5, x equals 6. So the solution to this is x equals 6, y equals minus 1.5. Okay, so for this one, we want to look at this straight line has this equation. We want to find the gradient. There's some other questions. Remember, for any straight line, the general equation for any straight line is y equals mx plus c. This m is the gradient, and this c is the y-intercept. So if I look at this equation that they give me, it's not written in this form. So I would say my first thing to do is try and rewrite it so it looks like this. So I'm going to add 2 y's to both sides. I'm going to get 3x equals 15 plus 2y. I'm going to minus 15 from both sides. 3x minus 15 equals 2y. Or we could write 2y equals 3x minus 15. And then I'm going to divide everything by 2 to get y equals 1.5x minus 7.5. So part A just says find the gradient of the line. Well, the gradient of the line is just 1.5. And part B says find the coordinates of the point where the line crosses the y-axis. So that's the y-intercept, but it's the coordinates of the point. So it crosses the y-axis at minus 7.5, but the coordinates of that, the x-coordinate 0, the y-coordinate's minus 7.5. Okay, then part C says find the equation of the line that is parallel to L and crosses the x-axis at minus 2, 0. So if two lines are parallel, that means they have the same gradient. So our new line that we're looking at must have the same gradient as this one of 1.5. So I know that I can write y equals 1.5x plus c. The gradient must be 1.5. And these questions will always kind of follow this same pattern. We then need to work out c. And if you look in the question here, they give us a point on the curve, or on the line, sorry, not the curve. And we always use that point on the line to substitute in to work out c. So we're given the point minus 2, 0, which tells us when x equals minus 2, y equals 0. So y is 0. If x is minus 2, that's 1.5 times minus 2 plus c. 1.5 times minus 2 is minus 3. Add 3 to both sides. C is 3. If I just put that back into this equation up here, I'm going to get y equals 1.5x plus 3 is the equation of your line. Okay, question 5. It's asking to express GH as a product of prime factors. So GH means G times H. So what they're asking you to do is say what would G times H be? So that would be 2 cubed times 3 times 7 squared, because that's G. And then I'm going to multiply that by H, which is 2 times 3 times 7 cubed. And I want this as a product of prime factors, so I want to leave it as this multiplying together. So if I simplify that, I've got 2 cubed times another 2, so that's 2, 4. Then I've got 3 times another 3, so that's 3 squared. 7 squared times 7 cubed would be 7 to the power of 5. And then for B, it's just saying, if G divided by H is this, find the values of A, B, and C. So G divided by H will simply be 2 cubed times 3 times 7 squared divided by 2 times 3 times 7 cubed. So remember, when we divide, we subtract the little indices. So 2 cubed divided by 2 to the 1. So 3 take away 1 will be 2 squared. This is 1, take away 1 in the 3, so they'll just cancel. So that'll be 3 to the power of 0. And then 7, we've got a squared, take away cubed, so 2 take away 3 is minus 1. So A is 2, B is 0, C is minus 1.